is fermentation. Here's a picture of a cheese, and like it says, that the flavor of cheese is made by lactic acid bacteria, and I'll detail that later. One of the things that's really interesting about fermentation and most of these food of ways of producing food with microbes is to basically let that product, let that food spoil, and generally in a very controlled way. But so say here with the cheese, transforming milk into that other additional food product is a good thing for us. Okay. Lactic acid bacteria are a class of bacteria that the one common feature is that they produce lactic acid. And lactic acid is part of metabolism, and one of the very first things that happens once sugar is being degraded by a cell. You can see we have a number of different milk products and vegetables that we use lactic acid bacteria in order to make. There are only a few of the meats that we use, but it does happen. Okay, so I think one of the biggest things we think about are cheese, yogurt, and sauerkraut as those things which are used to produce food. Okay, so here's what I was saying before about the lactic acid and where we get that lactic acid from. So if you are coming into the system, okay, you'll get glucose, and the glucose will be converted by the glycolysis cycle into pyruvic acid. And once we get to pyruvic acid, there are a number of different pathways that pyruvic acid can be transformed. On the left, you see that lactic acid, pyruvate can be made into lactic acid, and that's where we get the majority of our cheeses. Pyruvate can also be used to make alcohol, and at the upper right, one of the very kind of tragic things about this fermentation process is we can get gangrene. One of the keys to fermentation is that this is all happening anaerobically. These byproducts or conversions from the pyruvic acid only happen where there's no oxygen present. Vinegar is one of the food products that we know that bacteria produce, and it has been known for a very long time that we can convert alcohol into vinegars, and there's certainly some evidence that 3,000 years BCE we have had vinegars around. So the key to any vinegar is that you're oxidizing the ethanol. Okay, so the food might produce the alcohol as the first part, and then that alcohol is then converted into acetic acid. Now, the vinegar that we use at home for culinary purposes is about 5% acetic acid, and if you have vinegar that's used for pickling something like cucumbers to make pickles, that would be about 18% acetic acid. So here are some examples, um, culinary examples like a malt vinegar or rice wine vinegar. Um, all those things are just different types of vinegars and have very different flavors, but they're all the same process of taking alcohol and turning it into the acid. Okay. So it's really a two-step process to make vinegar. The first is the anaerobic fermentation of sugar into the ethanol, and that is done by yeast. So there's the first place that a microbe is present is important to us for this. Second, we can oxidize that ethanol into acetic acid, and the two main bacteria that do that are Acetobacter and Gluconobacter. And Acetobacter is definitely the most prominent of those. Okay. One thing that I want you to note is that the making of the ethanol is an anaerobic process, so we can't have any oxygen around. But in order to oxidize that ethanol into acetic acid, that has to be an aerobic process. Acetobacter and Gluconobacter are both gram-negative bacteria, and they're strict aerobes, which means they can't live at all when there's no oxygen. Okay, they have to have an aerated environment. And the Acetobacter is a little bit better at making vinegar than the Gluconobacter, although both can do it. Okay, there are a number of fermented vegetables. The ones that come to mind are sauerkraut and kimchi. There are some other fermented vegetables, like I said, sauerkraut. We can have certain types of legumes, some potato salads, and there are a number of bacteria that are doing this fermentation, and they're generally in the categories of Lactococcus and Lenococcus. And you can see on the right that not only are we transforming the food a little bit, but we can also add a lot of vitamin content. Okay, so one of the general things, the niacin is produced, and if you look under the delicacy salads, one of the great things about fermented food is that it's extending the shelf life, and that's probably where this was first developed for people, that they were looking for ways to store food before there was refrigeration. Okay. Kimchi is a Korean dish that becomes a major part of the Korean diet. Now, one of the things you see at the bottom there, that about 200 grams per day are eaten in the winter, and in a way this makes sense, because like I was just saying about the storage, the kimchi was produced originally to be able to store the cabbage for a long time. So the majority of a kimchi is some sort of cabbage, same way as with sauerkraut. Okay, we can also have a lot of radish, garlic, peppers, onions, and ginger, and these are all just flavor additives that are going to make the cabbage good after storing for so long. Um, One of the keys of kimchi is that it's generally very spicy. Okay, um, so that the food gets really transformed into a very hot substance. Okay. Uh, Now for sauerkraut, um, we generally do this by starting with no starter culture. So these are only bacteria that are coming in there naturally. And it's not a very difficult process. Okay, you just take your cabbage, um, shred it up, add 3 to 5% of salt, put it into the vat, cover it and seal it, allow it to ferment. Then commercially, we would pasteurize it to get rid of all the bacteria, and then finally to package it. Now this is a graph of the changes that happen to sauerkraut while it's being made. Um, and one of the things chemically that you notice is the pH. So the triangles are the pH, and so the pH goes down pretty significantly from the start to the end. Uh, the open circles, okay, are the lactic acid bacteria, um, and then we have an increase in the total number of bacteria, but the ones that are sort of the most important and will rise the most during sauerkraut production are the lactic acid bacteria. The most common of the bacteria in sauerkraut is Lenococcus maranites, and this is just, again, it's naturally occurring. Okay, it's coming in from the air in order to make it, and we also have just a mixture of lactic acid bacteria that are going to be present. A couple more vegetables that are fermented are olives and pickles. Um, a green Spanish style olive is first treated with lye and then fermented, and the black olives just aren't treated with the lye. You put a decent amount of brine into it, so it's again maybe a 2 to 3% salt solution, and the main bacteria for the olives is Lactobacillus platyrium. Now for pickles, we do a very similar thing to the black olives, and here we have just Lactococcus bacillus sort of in general, and then Lactococcus brevis is one of the major bacteria that are used. Now, for pickles and olives, those are not really starter cultures. These are just bacteria that are coming in naturally. Okay, it takes quite a while to ferment pickles, but or to make pickles from cucumber, and so 8 weeks of fermentation, and we're going to increase the percentage of acid from 0 to 1.2% by the end of that. Our next big area where microbes are used to make foods are cheeses. And in general, cheese is coagulation of the protein casein from the casein is from milk. Okay, and we can either do it with or without renin, and renin is a protein that's found in part of the stomach of calves, and one of the things that we think were happening is that the milk was being stored inside of the calf's stomach, and then the renin got into it, and also the stomach was contaminated with lactic acid bacteria, which helped transform the cheeses into the different types. Okay. There's a video on how to make cheese, and I'll leave the details of the cheese production to that video. Basically, you're going to add the lactic acid and the renin and coagulate the proteins. Then after you get rid of all the liquid, the whey, you store this for a while so that the bacteria are allowed to flavor the cheese properly. There are a number of different bacteria that are used in the cheese making process. The majority of these are lactobacillus, and one of the keys of being a lactobacillus is that you're longer than you are wide. Okay, so these top three are lactobacillus. This one is not quite as long as the Lactobacillus delbrueckii, but they're all fairly large rod-shaped bacteria. We can also have things like Pediococcus, which is a diplococci, or Lactobacillus brevis. Again, the lactobacillus is really the key to many of these cheese productions. And if you look at the number of bacteria, okay, as the cheese is ripening, okay, you'll start off with a fairly low number of the non-starter lactic acid bacteria and a high number of the starter culture. And then as it ripens, there's an increase in the non-starter lactobacillus, but the Lactococcus starter will decrease over time. Okay, so there's a real community going on here, and the population dynamics are pretty extensive, and that's why cheese production is not really an easy thing to do. Okay. The last food category that I think we should mention is bread, and it's sometimes it's easy to forget about bread in terms of the microbiology of it, but the biggest thing to worry about or to think about when you're thinking about bread is that it's the yeast that are making it rise. Okay, so the ingredients for bread are fairly simple, and the most important thing is that the dough gets kneaded with the yeast so that the bacterial, or sorry, the yeast will produce gas, and that's what gives the rising. Okay. So just in summary, there are a number of bacteria that are, or sorry, a number of yeast that are used in food production. Um, we've talked about wines and beer, things like vinegars or breads, and all these things are either making uh, the alcohol to be used for to be used as the final product, or in something like a bread, um, there we're having CO2 production, so that's what causes the bread to rise.